Today we are looking at atmospheric pressure. We are looking at atmospheric pressure. So for us to understand atmospheric pressure, we must know the word atmosphere. What do we mean by atmosphere? Right from primary, the science teacher must have mentioned the word atmosphere. Now, atmosphere simply means the space above the Earth's surface. Now, the space which is above the Earth's surface is full of air. And wherever we are, there is air. So the atmosphere is made out of air. Is made up, rather, of air. And this air has a force on Earth. So if this air has force, it means it exerts pressure on Earth. So whatever is on Earth receives this pressure. That's why here if you look at this, we have said the atmosphere is made up of air. The atmosphere is made up of air, which exerts a force on Earth. Thus, it also exerts pressure called atmospheric pressure. So this is a pressure which is exerted on Earth by air in the atmosphere. Now, what is the amount of atmospheric pressure that the Earth receives? The amount is approximately 100,000 newtons per meter squared. Now, we are using the word approximately because somewhere it may be more, somewhere it may be less on Earth. But on average, approximately 100,000 newtons per meter squared. Now, is it true that this pressure exists? Scientifically, we can prove whether atmospheric pressure is there. Now, this leads us to the next subheading. Evidence of existence of atmospheric pressure. Evidence of existence of atmospheric pressure. Now, for us to prove that there is atmospheric pressure, I want you to look at this diagram. Let's begin with this one. When you look at this diagram, supposing this is an object on Earth, you see these arrows? They are in all directions. So this is how atmospheric pressure acts on every object which is on Earth, in all directions. So assuming inside you, if this is a human being, inside your body you don't have pressure, because this pressure is squeezing you. So you need another pressure inside you to balance, the one which pushes from inside out. Otherwise, if there is nothing like pressure inside, so that the only pressure which is exerted on you is from outside, you end up being squeezed like this diagram. Now, let's go to the subheading again. Evidence of existence of atmospheric pressure. We can prove scientifically, we can prove experimentally whether atmospheric pressure is there or not. Let's look at this question. The question says, describe an experiment to show that air, there are some words missing here, that air in the atmosphere exerts pressure. Describe an experiment to show that air in the atmosphere exerts pressure. Now, for us to do this experiment, we need some things with us, which we call apparatus. Now, looking at this diagram, you realize that we need a source of heat, we need some water, we need a metallic can, a container, this one, made out of a metal. Why not plastic? Because when we heat plastic, it will melt. So we need a metallic can. Now, once we have all this, what do? We also need this metallic can to have a cover. But as per now, we are going to begin the experiment when the cover is not there. Now that we have all these things in place, what do? The first thing is we get some water, we pour inside the metallic can. I want you to look at the amount of water which has been poured there. It does not even reach halfway of the metallic can, about a quarter. So you need some water, like you pour inside in the metallic can, like a quarter way. Now, after pouring the water, what else do? You heat the water until it boils. That's why you see this word, water boiling. Heat this water until it boils. What is the reason for heating this water? Now remember, before you poured this water inside, even after pouring, there was air in this metallic can because this part was open. Now, the reason why we want this water to boil is, one, we want steam to be produced. This steam is going to drive all the air which was inside, so that the only thing which will remain occupying space here will be steam. So we only need steam here. So steam is going to drive off all the air which is there. Now, after doing that, let's go, this is part A. The next thing we are going to do, we are going to put, when you look at this diagram, you realize that there is a difference between this diagram and this one. The difference is here there is no heat, but here there is heat, which means heat has been removed. Then another difference is here the cover has been put, but originally the cover was not there. Now they'll put the cover, which we call a lid. You can call it a lid or you call it a stopper. Then another thing which is different here, there is cold water being poured here. So what do? If we put this in words, the next step is we remove, what do we remove here? We remove the source of heat. So we get our metallic can, we remove it from the source of heat, and then we make sure we put the cover, which is the lid, back, and we pour the cold water. Now, what is the reason of pouring cold water? Before you pour the cold water, there was steam inside here. Now, this steam has pressure, which means there is a pressure inside created by steam. Now that you have covered, it means this steam has nowhere to go. So there is pressure inside. Meanwhile, outside there is also pressure. Which pressure is outside? It is atmospheric pressure, as I showed you in the first diagram. Now, this atmospheric pressure is acting. Maybe let's understand from this diagram. You see these arrows? This is external atmospheric pressure. External means outside. So outside this container, after you have put the cover, atmospheric pressure is acting. It is squeezing it. But there is also steam inside. There is pressure due to steam. So steam is pushing out while atmospheric pressure is pressing in. But here you realize that the shape of this container will remain the same. It will not be affected. Why? According to the arrows, the external pressure, which is atmospheric pressure, is balancing, is equal to the internal pressure. So once you put the cover, remember there's pressure inside pushing out because of steam. Here we have said internal pressure due to steam. But there is also external pressure. So if you have two people pushing you in both directions, one is pushing you from the front backwards, another one is pushing you from the back part frontwards, and they are using the same force. what will happen to you? You will not move. Your shape will remain the same. So this is what happens before you pour cold water. Now, should you pour the cold water, now what happens? When you pour cold water, this cold water is going to affect steam which is inside in two ways. One, it is going to make the steam to cool. Then it will also make the steam to change into water, to condense, the process we call condensation. Now, once this steam cools, and remember this steam was the one responsible for internal pressure. It was the one balancing with atmospheric pressure. Now that you have cooled the steam, you have now reduced the pressure which is inside, because the pressure inside here was created by steam. Now that the steam has cooled, the internal pressure, the inside pressure, which we said here, remember this? Internal pressure due to steam. This pressure here is now not going to be there. Because you have poured cold water, the internal pressure which is due to steam is going to reduce, because steam is going to cool and condense. Now, once internal pressure reduces, what happens to the shape of this metallic can? When they were balancing, when internal pressure was balancing with the external pressure, the shape remained the same. Now the pressure inside has been removed by pouring the cold water. So what happens? We now remain with the external pressure alone. Internal pressure is not there. So the pressure which was pushing this container out is not there. So we only remain with the pressure which is pushing it in. So the shape of the container changes. So this is going to be our observation. Our observation is the can crashes inwards. The can crashes inwards. So now let's proceed. Supposing somebody says, describe an experiment to show that air in the atmosphere has pressure. That person is asking you an experiment to prove that atmospheric pressure is there. So this is exactly what we have been talking about. Now, the name of this experiment is called the crashing can experiment. Why does that name come in? Because we said in our observation that the can, the metallic can, crashes inwards. The atmospheric pressure crashes the can inwards. That's why it is called the crashing can experiment. Now, how do you answer the examiner? Remember the diagrams I was showing you. So you handle them one by one. Normally, first things must come first. Don't begin with the last thing. So when you look at what I showed you in the first diagram, the first thing is pouring water in the metallic can. But when you are giving the examiner you're answering, use past tense. Don't say pour water in the metallic can. You say some water is poured in a metallic can. For example, quarter way. Remember I showed you the size of that water, around a quarter. So some water is poured in a metallic can. For example, quarter way. You see, this is the beginning of your, now you begin getting your marks. Now after pouring water, what happens? The water is heated until it boils without the stopper, that is the cover. The next thing is, I told you the reason for heating is to produce steam. What is the work of steam? The steam drives out all the air. So that is the work of steam, to drive out all the air. Then after that, you move on to the second diagram. The can, that is a metallic can, is tightly covered and removed from where? From the source of heat. The can is tightly covered, you cover it and you remove it from the source of heat. Then after that, we go to the next diagram. Okay, this is still the second diagram. Cold water is poured on it. Now, what does the cold water do? it affects the steam, so the steam cools. You see, the steam cools. Apart from cooling, and condenses inside. And once this steam cools and condenses, it is going to affect the pressure inside by reducing. So you say, creating a low pressure inside the can. You see, so cold water is poured on it. The steam cools. After steam cooling, it also condenses inside, and by doing that, it is creating a low pressure inside. That is reducing the pressure inside. Then you now go to the last diagram. The excess atmospheric pressure crushes. The excess atmospheric pressure crushes the metallic can inwards. You see? And why does that? Why do you think the atmospheric pressure crushes the can? Because we are using, you see this word excess? It means the pressure outside, that is atmospheric pressure, is more than the pressure inside. After the pressure inside has reduced, now this one becomes what? Excess. The excess atmospheric pressure crushes the can inwards, showing that, meaning that air in the atmosphere exerts pressure. Meaning that air in the atmosphere exerts pressure. Now, each of those steps, you get the marks. That's why I started with the diagram. If you understood that diagram very well, then putting them in words becomes very easy. Now, there's a next question here. State 3 applications of atmospheric pressure. State 3 applications of atmospheric pressure. 3 marks. Each one is 1-1. Now, there are machines which use atmospheric pressure. We are going to look at them later. One is called a force pump. There's another one called the common pump. You either call it a common pump or you call it a lift pump. But another word for this is also a borehole. Then we have the syringes, which doctors use for injections. They also use atmospheric pressure. Then we have the rubber suckers. And then we have the drinking straws. When you are drinking your soda, atmospheric pressure helps you. Now let's look at the effects of atmospheric pressure in daily life. What are some of the effects of atmospheric pressure in daily life? One of the effects is nose bleeding. Have you ever seen somebody experiencing nose bleeding? There are so many reasons which cause that. One of them is atmospheric pressure. Now, we are not saying it is the only reason why. Somebody could be sick or other causes, but one of them is atmospheric pressure. Now, let's explain this. Normally, nose bleeding happens when it is very hot on hot days. So that's why here we are saying the first effect, on a very hot day, nose bleeding, on a very hot day, nose bleeding may be experienced by a bicycle rider. Now, why do you think a bicycle rider may experience nose bleeding on a very hot day? The reason is about atmospheric pressure. The pressure inside our bodies and the pressure outside. Once they are not balancing, inside our body we have blood pressure. And then outside we have external atmospheric pressure. So there is internal pressure, that is inside due to blood pressure. Then we have external pressure due to atmospheric pressure. So we are giving the reason. This is because the cause of nose bleeding, her internal blood pressure, that is for the bicycle rider, becomes greater than the external atmospheric pressure. So once the pressure inside your blood becomes more than the pressure outside, what happens? You remember? The pressure outside is pressing you inwards, but the pressure inside your body due to blood is pressing you outwards. Now, if the one inside becomes more than the one outside, what happens? It will, the blood pressure, if it becomes more than atmospheric pressure, it is going to cause blood vessels to break, the membranes. So we are saying this is because her internal blood pressure becomes greater than the external atmospheric pressure. And when the internal blood pressure becomes greater than external atmospheric pressure, what happens? This forces the membranes to break. It forces the membranes to break, the blood vessels to break. And once they break, automatically nose bleeding occurs. So that is one. Now, another thing which can also cause nose bleeding, still atmospheric pressure, but at a different place. This one is when you are at a very high altitude. You see, altitude means the height above sea level. So at high altitudes, nose bleeding is also common. This is because of the same reason. The internal blood pressure overcomes. When we say overcomes, it means it becomes more. It overcomes the lower external atmospheric pressure there. So at a high altitude, atmospheric pressure is very low. So our internal blood pressure becomes more than external atmospheric pressure. And once the blood pressure becomes more, automatically the membranes will break and nose bleeding occurs. So we are giving you an exercise here. It reads, explain why a bicycle rider may experience nose bleeding on a hot day. 3 marks. Explain why a bicycle rider may experience nose bleeding on a hot day. 3 marks. B, that was A. Now B, state one effect of atmospheric pressure in everyday life. 1 mark. State one effect of atmospheric pressure in everyday life.